Welcome to AI Frontiers. Today's focus is on advancements in computer science, specifically the area of learning, as reflected in a collection of research papers. The subtitle is Exploring the Frontiers of cs.LG Research. These papers were published on May 10, 2025, on the arXiv preprint server. This episode synthesizes key themes, findings, and future directions from these works. We will be looking at a collection of research papers in computer science learning, reflecting modern AI techniques and applications. This episode delves into the field of computer science learning, often abbreviated as cs.LG, which serves as a cornerstone of modern AI. At its core, cs.LG involves the development of algorithms and models that enable computers to learn from data. This core ability to learn from data drives the automation of complex tasks and facilitates intelligent predictions. The impacts of this field are far-reaching, spanning areas such as healthcare, finance, robotics, natural language processing, and many others. Ultimately, it enables machines to learn from data, which has broad impacts. A prominent research theme emerging from these papers is the pursuit of efficient and scalable machine learning models. As datasets continue to grow and models become increasingly complex, there is a pressing need to address the growing computational burden. One focus is on compressing large language models, with the goal of making them more suitable for deployment on resource-constrained devices. Another approach involves distributed training, which can significantly reduce model training time by training models across multiple machines. As an example, the work by Imani et al. Explores QoS efficient serving using partial runtime reconfiguration. Efficiently serving large language models is an area of increasing focus. Another significant research theme revolves around interpretable and explainable artificial intelligence, or XAI. Deep learning models are often considered black boxes, posing a challenge in understanding their decision-making processes. The overarching goal is to increase transparency and understand how these models make decisions. This involves developing techniques for model understanding and making models more transparent. For example, Weeratunge et al. Use SHAP values for interpretable Bayesian optimization, highlighting efforts to make models more understandable and transparent. A key issue addressed in these papers is the need for robust and reliable machine learning, focusing on resilience to real-world challenges. Real-world data is often characterized by being noisy, incomplete, and vulnerable to attacks. Researchers are focused on making models resilient to these data imperfections. This involves techniques for mitigating attacks and handling missing data, with the goal of ensuring models perform well, even in adverse conditions. The work of Ribeiro et al. Explores robust causal discovery in the presence of confounding variables. Ultimately, it's about ensuring models perform well, even when conditions are less than ideal. SHAP, which stands for Shapley Additive Explanations, values are a concept crucial for understanding feature importance. SHAP values help explain the output of a machine learning model. They quantify the contribution of each feature to the prediction, allowing for feature importance ranking, model debugging, and fairness analysis. They provide a way of explaining how the prediction changes based on features. SHAP values were used by Weeratunge et al. To refine underwater acoustic metamaterial coding design. Several key findings emerged across these papers. Imani et al. Demonstrated an 85% turnaround time reduction in large language model serving. Weeratunge et al. Found that SHAP values effectively guide Bayesian optimization. Ribeiro et al. Introduced a novel score that improves robust causal discovery. Lee et al. Presented a concrete method for enforcing the right to be forgotten in machine learning models. Finally, Pan et al. Showed that video information enhances offline reinforcement learning. The methodologies employed in these papers showcase a synthesis of approaches. Deep learning techniques, including convolutional neural networks, CNNs, Recurrent neural networks, RNNs, and transformers are utilized for image recognition, natural language processing, and time series analysis. Bayesian optimization is used for black box function optimization. Causal inference is employed to understand relationships between variables. Reinforcement learning. Particularly offline reinforcement learning from static datasets is also prominent. The integration of diverse techniques is shown to be important. Reinforcement learning, or RL, is a machine learning paradigm where an agent learns to make decisions in an environment. The agent receives rewards or penalties based on its actions, and the goal is to maximize the cumulative reward over time. Offline reinforcement learning learns from a static dataset without environment interaction. Pan et al. Used reinforcement learning to enhance offline learning with video data, demonstrating its practical application. One selected research paper by Chung et al. Focuses on paired autoencoders for solving inverse problems in scientific computing. The objective is to develop a new framework for solving these inverse problems. The method involves training two linked autoencoders in data and quantity spaces. The findings indicate that this approach is effective for both linear and nonlinear problems, specifically in seismic imaging and in painting. The significance of this work lies in its combination of data-driven and model-based approaches, demonstrating an effective approach to problem-solving using autoencoders. The selected research by Ribeiro et al. Addresses robust causal discovery, specifically focusing on latent confounding and unfaithfulness. The objective is to develop a more robust method for causal discovery. The method uses a novel non-parametric score for assessing partial ancestral graphs. The findings show that DCFCI outperforms state-of-the-art methods. The significance of this work lies in its ability to handle latent confounding, unfaithfulness, and mixed data, making it a valuable tool for causal discovery in real-world applications. The selected research by Pan et al. Centers on video-enhanced offline reinforcement learning, which involves leveraging external video data. The objective is to improve offline RL with unlabeled video data. The method, called VORL, is a model-based approach that uses video for a world model. The findings demonstrate substantial performance gains in visual-motor control tasks. The significance of this work lies in its ability to transfer common-sense knowledge to the RL agent, opening opportunities for RL in data-scarce environments. Looking ahead, several future directions are anticipated in machine learning research. This includes developing robust and reliable models that can withstand attacks and noise. Creating interpretable and explainable models is another key area, as is addressing the ethical and societal implications of machine learning, such as fairness and bias. Furthermore, there is a growing emphasis on development of privacy-preserving methods. Combining machine learning with robotics and other fields is expected to yield further advancements. This synthesis was created using AI tools, including GPT Google using models, Gemini 2.0 Flash for text generation, TTS synthesis using OpenAI for speech, image generation using Stable Diffusion for visuals, describe visual elements textually, content reviewed by a human expert to ensure accuracy and coherence, acknowledgement. While reviewed, some oversights may exist. All references provided. Subscribe to AI Frontiers for more insights into AI advancements. You can find us on social media for exclusive content and updates. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer, this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.